let's use the leading coefficient test and that table that was on the previous slide to help us out with these next few examples. So if we take a look at this first problem, we have f of x equals negative 2x cubed plus 5x squared minus x plus 1. I need to know what n is. Now if you remember from the leading coefficient test, we had that f of x equals a sub n times x to the n. And what we're talking about when we say n is this. And that would be your degree, which in our case is 3. Then for a sub n, which is I have LC, which is our leading coefficient, that would be this right here, so negative 2. And then because our degree is odd and our leading coefficient is less than 0, that means, according to our table, that it is going to rise left, and I'm going to make an L with a circle to abbreviate left, and it will fall to the right, which means that it look something like this, or possibly with a dip in it. And so then looking at example B, we have f of x equals x cubed plus 5x squared minus 4x minus 20. Now if you notice, this has a lot more stuff involved with it, which is what you need to be able to do. So we look here, I see that our highest power is cubed, which means that it is a degree of 3. And a degree of 3 means it is going to have a snake or S shape. And our behavior, we look at this, 3 is odd, our leading coefficient is 1, which means it's bigger than 0. Therefore, it is going to fall to the left and rise to the right. And the name of the polynomial, when it's a degree of 3, that makes it cubic. And I count here 1, 2, 3, 4 terms, so that makes it a polynomial. And it has 4 terms. And you did learn these in the beginning of chapter 6. We're just going to reiterate them now. Y-intercept, remember, is going to be 0, comma c, or your constant. In this case, our c value is here, so our y-intercept is 0, negative 20. X-intercepts, this is where we get into factoring. I see here that I have 4 terms, so I am going to factor by grouping. Make this a plus a negative, and we can go ahead and factor by grouping. I see in this first one here that I have an x squared in common, so I will pull out an x squared, and that leaves me with x plus 5. And then in the second one, I see that I have a negative 4 in common, and that leaves me with x plus 5. Looking at our factoring, I have an x plus 5 in common, so I'll have that as my first binomial. And then I take what's left over, which I have an x squared minus 4. Then I see that x squared minus 4 is a difference of squares, which means that I end up having x plus 5 times x plus 2 times x minus 2. And so now that I've got this, if you remember, zero product property says set it equal to 0. And we did this in day 1. And so if x plus 5 equals 0, if I subtract 5 from both sides, I get x equals negative 5, which means that one of my x-intercepts is negative 5, 0. If x plus 2 equals 0, I subtract 2 from both sides and get x equals negative 2. So my next x-intercept is negative 2, 0. And finally, if x minus 2 equals 0, I add 2 to both sides and I get x equals 2 with an x-intercept of 2, 0. Now that I have this information, I can start plotting my points. Since I have 0, negative 20, and negative 20 is a little bit on the big side, I'm going to go up by 2's. And so I'm going to mark down that my y-axis is by 2, and x-axis, I can actually keep it by 1. So I'll label those. So I have here 4, 6, 8, 10, 12, 14, 16, 18, 20, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20. And then on the y-axis, or x-axis, I've got 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Then I can plot my points. I have my y-intercept at 0, negative 20. I have x-intercepts at negative 5, 0, negative 2, 0, and 2, 0. And I know that this is supposed to, according to my stuff up top, it says it falls to the left, which means I go down this way. It rises to the right, so I go this way. And so I know that it goes like this. And I have it goes somewhere up here. Now it is just a sketch, but we want to be a little more accurate than that. So being that halfway would be 3.5, but I don't really want to stick 3.5 in here and have to deal with all these decimal points. Although you can, I'm going to choose to find out, since negative 3 is kind of close to halfway, I'm going to find out what f of negative 3 is. So that means I'm simply going to substitute that in and to my original equation, which my original equation, that would mean that it would be negative 3 cubed plus 5 times negative 3 squared minus 4 times negative 3 minus 20. Negative 3 cubed is negative 27. Negative 3 squared is 9 times 5 is 45. Negative 4 times negative 3 is positive 12, and then minus 20. If I go ahead and combine all of that, I end up with 10. So when I am at negative 3, I'm at 2, 4, 6, 8, 10. And so what I can do now is actually sketch about what this looks like. It'll go probably and vertex max out a little bit past that, since that's close to the halfway point. Now, while your graph doesn't have to be perfect, this is a pretty good sketch of what it'll look like. We'll do one more example in the next video.